Peeps! Math Bootcamp, second phase, solving for a variable. Here we go. SADMEP. What? SADMEP. That looks awfully familiar. But it sounds peculiar. SADMEP. What the heck is that? Okay. I think you figured it out by now. Yes. Yes. Okay. We can use the process that we used in the last video to evaluate an algebraic expression, except we're going to invert it. We'll flip it backwards. SADMEP is just PEMDAS in reverse, the order of operations in reverse, to solve for a variable. That's the technique that we're going to use to solve for a letter in an algebraic expression. So we're going to use only the symbols and no numbers in this case. Therefore, we look for subtraction or addition, operations of subtraction or addition. Secondly, division or multiplication. Third would be exponents. And fourth, parentheses. Parentheses. Let's do some examples. Zebra 1. We got, hey, this should look familiar actually. This is the same equation that we had last time. Same with example 2. But we're going to solve for a different variable. Currently, this is solved for d. And example 2 solved for v0. So we're going to solve for v0 in equation number 1. Another equation in motion. So here we go. First thing we got to look for with SADMEP is whether or not subtraction or addition, those operations, are connected to the variable of interest that we want to isolate, which is v0. And we look around and we do see that v is connected by the operation of addition, but guess what? They are formed within parentheses. So we can't really mess with them because the parentheses are last. We have to deal with that last. So we look and see what else is connected over here, what other aspects are connected to v0. And we look at 2 and t are connected. We want them to move to the other side of the equation to isolate it. So we got 2 in the denominator and t over here. They're connected by division and multiplication respectively. So we're going to deal with those first. There's actually no other terms subtracted or added that are not within the parentheses. So we go to division and multiplication. Okay? So what I'm going to do in order to isolate the items in parentheses is multiply both sides of the equation by 2 and I'm going to divide both sides by t. So here we go. It's going to look like this. 2d divided by t equals parentheses, although we can get rid of them now because nothing's attached to them, v0 plus v, like that. We'll just kind of keep it consistent over there. So on both sides of the equation, essentially, what I did, secret, is multiply both sides by 2 and divided both sides by t, and we get this neat expression over here. All right. Well, we can actually break down the parentheses because nothing's attached to them. Whew, look at that. My finger does it perfectly. What a great eraser. Thank you, finger. Oh, you're welcome. v0 plus v. So now, in order to isolate v0, it's attached by the operation of addition. So what we have to do is subtract both sides by v in order to isolate v0. So we have minus v over here. And so our final expression becomes v0 equals 2d divided by t. v0 equals 2d divided by t minus v. And there it is. We have isolated and solved for our variable v0. Beautiful thing. Okay, let's do example number 2. This time we're going to solve for a, which is acceleration. Okay, here's the deal. A is over here. It's attached directly by 2 and d by the operation of multiplication. And we also have subtraction over here. Okay, the thing is, this whole thing is contained within the radical, okay? So that means it's kind of all set within parentheses, and basically we gotta kind of take care of that first before we can do anything, okay? So we would love to go through this operation, but we notice that it's sort of tied up here in that radical. So here's what we do. We're going to square both sides to undo that radical. All right, square v naught, and we're going to square the square root, undoing it. And so what we'll have over here is v naught equals v squared, I should say v naught squared, equals v squared minus 2ad. Fabuloso. Okay, now that that's been taken care of, we look back at SADMEP. Is there anything attached to the a by way of subtraction or addition? And the answer is yes. The v squared over here is attached to this expression which contains a, so we want to deal with it first. We want to subtract both sides by v squared. So we have minus v squared. I'll duck so you can see that. Minus v squared. Okay, so our next step says this. We now have v naught squared minus v squared, yep, equals negative 2ad, like that. Okay, good. All right, now what we've got to do is isolate a from this expression over here. So we've got a negative 2 and a d. So we're going to divide because they are attached by the operation of multiplication. So we're going to divide by negative 2d on both sides, like so. And I think this is it. That will be our isolation of a. So here we go. We have v naught squared minus v squared over negative 2d equals a, like that. Now we could switch this over because I don't really like the negative in the denominator, and we can write a as v squared minus v naught squared over 2d, like so. I'm going to box that in. All right. Hopefully in the picture you'll be able to see that a little bit better, but that's the process using SADMEP to isolate a variable, solve for it symbolically, because we're going to be doing a lot of that this year. The power of physics sometimes comes from its modeling equations. We'll be looking at many ways to represent a physical system, but certainly this is one of them. And the skill of isolating a variable like this is going to come in handy because we now have an expression that models this, and now at this point, if we wanted to, we can throw in different numbers that describe the situation for velocity and distance in this case. All right, that's what it is. Thank you. Morad, out.